These are the molar conversion test review slides. I would have your periodic table and the particle to mole to gram conversion factors open as you are completing these with me. All right. So first thing we need to know is molar masses and naming. So molar mass, because we in our mole to mass conversion factor, we have molar mass. Anytime we are asked to find that molar mass, or anytime we're asked to do a gram to mole conversion, we need to know the value of that molar mass. So write the name or the formula and then find the molar mass. So this first one, calcium hydroxide, we are going to need to write the formula out so we know how many of each particle or how many of each atom is in this compound. So we've got calcium. If I look at my periodic table, calcium has a +2 charge. Hydroxide, looking at my polyatomic ion list, which is on the back of that periodic table I've posted for you. Hydroxide, OH, that's a -1 charge. Then we do that drop and swap, so we need 2 OH groups and 1 calcium. So this compound is going to be CaOH2. OH2, the OH in parentheses, because we need 2 of both of those. So that is that compound. Now, in order to find the molar mass, we need to add up what the individual molar masses are for all of those. And so we have 1 calcium, so 1 times, and then we are going to just round to that nearest whole number from our periodic table. So 1 times 40, so that calcium here, 40.08, we're rounding to the nearest whole, plus we have 2 oxygens because we have 2 groups of OH, so that's going to be 2 times. Oxygen is 16, and then we need 2 times hydrogen, which each hydrogen is 1. So 2 times 16 plus 2 times 1. We add all of those up, and we get 74 grams per mole is the molar mass of calcium hydroxide, or we can write that as 74 grams of CaOH2 equals 1 mole of that CaOH2. So those are both ways we can write out that molar mass. If you are comfortable to find the molar mass of aluminum oxide, which is our next one in number 2, feel free to pause the video, or you can go ahead and do this with me. We already have the compound here, so then we just need to take into account how many of each we have. I have 2 aluminums. Looking at my periodic table, aluminum is 26.98, so I'm going to round to the nearest whole, so that is 27. Plus, I have 3 oxygens, 3 times 16, so I can use a calculator to calculate that out. So that's 102 grams per mole is the molar mass, or you could write that as 102 grams of Al2O3 equals 1 mole of that Al2O3. The benefit of this second way of writing it is that this is what we then easily are going to use in our conversion factors. All right. And I suppose we can write our name for this, because this one, aluminum, is a metal. This is an ionic compound, so aluminum. And then we have oxygen, oxide, changing the ending to IDE. Aluminum, we always know that it has a +3 charge, so it's not a transition metal, so you don't need to include the charge after aluminum. All right, next we have one-step molar conversions. And with this, remembering and using those molar conversions that are on the back of that periodic table that's provided, we know that 1 mole equals 6.022 times 10 to the 23rd particles, and 1 mole is also equal to that molar mass in grams. So those are our 2 conversion factors. that we can use as we are setting these up. And each of these should have, if they're one step, that means that we just need one of our conversion factors to start convert from what we are given to what we need to find. So looking at this one, how many grams are in 0.65 moles of Al2O3? So we are given moles of Al2O3. We are looking for grams. We've got 0.65 moles of Al2O3. I'm going to need a conversion factor to convert that to what I'm asking for. So we have moles. We see moles in both of these conversion factors, but looking at, well, which one has grams? Grams is in our 1 mole equals molar mass. So this is the conversion factor we're going to use. And I'm going to put my 1 mole in the denominator because I have mole here. I'm going to cancel that by putting that there. My molar mass is going to go then in the numerator. We always put what we want to end up with in the numerator there. And what needs to go in before those grams, though, is I need to actually put in what is that molar mass. And so finding that molar mass in grams. Luckily, we found that molar mass up here. That 1 mole is 102 grams. And so we can transfer that down here. 102 grams of Al2O3 are in 1 mole of Al2O3. And so that's where I get that from. Now we can go through, we can see that our units of moles are going to cancel. I can go through and do my calculation now. 0.65 times 102. And then I'm going to divide by 1, and I get 66.3. And then with this, we can keep, this is the exact number I get from my calculator, so I don't have to do any rounding. We can leave that there. But I do need to make sure that I'm putting in I'm including units. So grams of Al2O3, I need to include those units that didn't cancel. Those are get included in my answer like that. So 0.65 moles of aluminum oxide is equal to 66.3 grams of aluminum oxide. All right, now looking at, I'm going to fix this. Now looking at our 9.6 times 10 to the 24th particles is how many moles of magnesium chloride. Looking at this problem, we are given 9.6 times 10 to the 24th particles. So we can see that unit of particles up above is how many moles. Well, wanting to go moles to particles, we're going to need to use this conversion factor in this problem. We start by putting our given value, 9.6 times 10 to the 24 particles of MgCl2. I need to look at those conversion factors. We have one conversion factor that's going to get us directly from particles to moles that shows that relationship. And so I'm going to have, if I am starting with particles, wanting to get rid of particles, that means that I'm going to have that 6.022 times 10 to the 23rd. That's what's going to go in that denominator, is my particles of magnesium chloride. And then whatever that's equal to, that 1 mole, is what's going to need to go in my numerator. So 1 mole of magnesium chloride is going to equal 6.022 times 10 to the 23rd. Looking at our setup, my units of particles of magnesium chloride are going to cancel. So we're going to be left with those moles of magnesium chloride, which is what our problem asked for. And now I can go through and do my math. 9.6 times 10 to the 24th times 1, which is 9.6 times 10 to the 24th, all over, and then we're going to divide by whatever's in our denominator. That's 6.022 times 10 to the 23rd. And I get I got 15.9415. And let's round to 2 decimal places. I think that's what the directions on your test are going to say. So because there's a 1 after that 4, then we are going to just round and say 15.94. That 4 is going to stay. It's not going to round up, but we need to include units. Moles of magnesium chloride is going to be our final answer. All right, so for those one-step conversions, we're only using one of our conversion factors. Once we have a 2-step molar conversion, we're going to have to use both of our conversion factors. Which one goes first is kind of depending on what we were given first in the problem. So determine the number of particles in a 20-gram sample of nitrogen dioxide, NO2. And so we're starting with grams. In order for me to get to particles, I'm going to have to go from grams to moles and then moles to particles. I'm going to write down my given value first. I have 20 grams of NO2. That's my given. Now, as I'm setting this up, I'm going to take that molar mass part of that conversion factor. That's going to go in the denominator. The 1 mole part of that conversion factor is going to go in the numerator. So 1 mole of that NO2 over the molar mass of NO2 for that first conversion factor. We can calculate our molar mass. We need 1 mole of nitrogen. Nitrogen has a mass of 14 plus 2 oxygens. So 2 times 16. So that's going to be 46 grams per mole. And so I plug that 46 in for that molar mass here. So we've got that 46 grams is going to go in that denominator. If we were to stop here, our answer would be in terms of moles, but we want particles. So now I need to go moles to particles. In that second conversion factor, I have moles, so I am getting rid of moles. So that mole side of my conversion factor is going to go on the bottom. My particle side is going to go on the top of my conversion factor. And then we can see in our setup that what we want to get rid of is going to cancel my grams of NO2 and my grams of NO2. The units cancel. I'm not canceling the numbers, just the units to make sure my setup is correct. Moles of NO2 cancel. So we are going to be left with those units of particles, which is what our problem asked for. And now we can go through and do that calculation. So we're going to multiply anything in our numerator. We're going to go 20 times 1 times 6.022 times 10 to the 23rd. And I get 1.2044 times 10 to the 25th. And then I need to divide by anything in the denominator. So I'm going to divide by 46 times 1. So that's just dividing by 46. And then when I do that, I get 2.61826. That keeps going. Times 10 to the 23rd. Let's round to 2 decimal places again. So let's keep the tenths. And then we'll round to that second decimal place. There's an 8 after the 1. So this will round to be 2.62. We include that times 10 to the 23rd. That's scientific notation. And then we need to include our units that were in the top of our last conversion factor, particles of NO2. Done. All right. There are resources posted for you to review. Please reach out to your teacher if you have questions. So utilize the worksheets and the keys from throughout the unit. There were check-ins as well. There is a review worksheet. You do need to show work on your test, so please be practicing showing your work. Rewatch any notes videos that you might see, and note what specific concepts you are going to be asked to try or to complete on the test.